This week, for my 5.1 tutorial, we will be going over Chapter 13, Exercise 15, Testing Chemical Processes. So, testing chemical processes says, to test whether the mean time needed to mix a batch of material is the same for machines produced by 3 manufacturers, the Jacobs Chemical Company obtained the following data on the time, in minutes, needed to mix the material. So what we are given is a table showing the 3 different manufacturers and 4 samples from each manufacturer for the time in minutes that it takes to mix the chemicals. So what needs to be done from us is, for part A, we need to use this data to test whether the population mean times for mixing a batch of material differ for the 3 manufacturers using alpha equals 0.05. And for part B, we need to determine at the A equals 0.05 level of significance, use Fisher's LSD procedure to test for the equality of the means for manufacturers 1 and 3. What conclusion can you draw after carrying out this test? So for part A, we want to use the data to test whether the population mean times for mixing a batch of materials differ for the 3 manufacturers. Just like in last week's tutorial, the word differ is extremely important when we're creating our hypothesis. So because of this, we want to create a null hypothesis and an alternative hypothesis. So our null hypothesis, considering the word differ before, whether or not these mean times differ, we would use a null hypothesis of all of the averages are the same, or they do not differ. Our alternate hypothesis would be that some of them do differ, so the average for 1 is not equal to the average for 2, etc. So basically, any 2 of these mean times are different, not the same. So what we need to do for this is to make an ANOVA table in Excel. You can do this by hand, but through Excel it's a lot quicker and easier. So the steps for making an ANOVA table would be to first copy and paste your data table from the textbook into Excel. So for this, we have to do...
Are you recording yourself?
Yeah. So basically what we need to do is take the textbook graph table and turn it into the same exact thing, just in Excel. So the next step will be to click the Data Analysis button within the Data tab of Excel. So within the Data tab right here, we just need to click Data Analysis. And then you will have a little table pop up. So within that table, select ANOVA single factor right here, and then press OK. From there, you'll need to insert your data from the table into this ANOVA table software. So for the input range, you're going to take everything from the table that you just inserted, and then make sure to click that you have labels in the first row, because we don't want the 1, 2, and 3 to skew our data in any way. And since we know that our alpha is 0.05, we can just leave that as it is. And press OK, and you'll end up with an ANOVA table that looks just like this. So understanding the ANOVA table, basically we need to reject our null hypothesis if the F star or the F value is larger than our critical value. So our critical value can be found here in the ANOVA table. So our critical value is 4.2565. And our F value can be found there in the table. Our F value is 10.6364. So obviously 10.6364 is greater than 4.2565, which means that we reject our null hypothesis. So it can be concluded that there is a significant difference between the mean time for mixing a batch of materials for at least 2 different manufacturers. So for part B, we need to know at the alpha equals 0.05 level of significance, use Fisher's least significant difference procedure to test for the equality of the means for manufacturers 1 and 3. What conclusions can you draw after carrying out this test? So this is the Fisher's least significant difference equation, and we will be using that in this process. We also need to use the ANOVA table that we created in our last part of this problem to find all of our important values. So our t value can be found as our critical value right there. The MSE is the MS of the error, which is also known as the within group. So that would be our 4.8888888 value. And then NI in this case is the number for the first group up there. And then NJ is the number for the second group right there. Now this would make more of a difference if they each had different sample sizes, but because they have the same sample size, it doesn't make that much of a difference. So we type in our values here. And we get an LSD of 6.6549. So what does that mean? If the absolute value of the mean of 1 minus the mean of 3 is greater than the least significant difference, then the mean of 1 and the mean of 3 are different. So basically, the mean of 1 is 23 and the mean of 3 is 21. So if you subtract those, you get a value of 2. And our least significant difference found in the last slide is 6.6549. So obviously 2 is less than 6.6549, which means that the average for 1 and the average for 3 do not differ, which means that they are equal. So in this case, considering the conclusion that we came up with in the first slide, it would have to be either the average of 2 and 1 or the average of 2 and 3 that differ in order to make our rejection of the null hypothesis true. Thanks.